All right, let's talk about polynomial division. So we're going to specifically focus on synthetic division because I think for the majority of you guys, that is going to be what's most valuable to know for the SAT and just in general. Knowing polynomial long division is perhaps not quite as important as being able to just do synthetic division and go from there. So we're specifically going to look at synthetic division. So let's just do this by looking at a problem. So our example one is going to be, I want to take 8x cubed minus 8x squared minus 2x, and I want to divide that by x minus 1. Okay, so before I do anything, the first thing I want to do is make sure, one, that my polynomial is in standard form. So remember, standard form is where the powers are decreasing. So I've got 8x cubed, 8x squared, 2x. Okay, so the powers are decreasing. The second thing I want to check for is to make sure that I have, I'm not missing any powers. So in this case, I've got 8x cubed, cool. Next one is x squared, cool. I've got x to the first, cool. What I'm missing is my x to the 0th, and the way that I would go about slotting that in is to add a 0 for that missing term. So for example, maybe I would have 2x squared plus 1. Well, I would want to add in a 0x in the middle there because I'm missing that term. So it would be 2x squared plus 0x plus 1. All that really does is it becomes a placeholder so that when we do synthetic division, we don't lose track of spacing and making sure that when we write back in our powers, we write them in properly. It also has the potential to throw off everything past that point. So it's very important that we remember that placeholder, and as long as we place it in there, we don't have to know a whole lot other than just that it's holding the place of something that we're missing, right? And it's not false at all. If I say that I have 0 x's, that's the same as not writing it. It's just allowing me to do synthetic division properly. So once I've checked that it's in standard form and checked for missing powers, now I'm ready to start setting up my synthetic division. So the nice thing about synthetic division is it removes a lot of the writing, a lot of the tedious steps, and allows us to do a lot of division quickly. The downside is that it's a little bit quirky and it's maybe not overtly obvious to us what we're doing or why it works. But the first step after we've set everything up is to go and find all of my coefficients of my term that I'm dividing, right? So 8x cubed, the coefficient there is the 8 out front. Coefficient is just what we're multiplying something by, so I'm multiplying my x cubed by 8. The x squared I'm multiplying by negative 8. The x I'm multiplying by negative 2. And the constant term is just in this case 0, but that is in fact still a coefficient. So I've got 4 terms, I've got 4 coefficients, so now I want to write these out. So 8, I'm dropping the x's, negative 8, and I'm bringing the negatives along, negative 2, and 0. So first step after I've set everything up is I take all the coefficients and I write them down in order. Right, so we could go backwards and add back in the x cubed, x squared, x, and x to the 0, and it would still remain true. Okay. Next, I want to put it in kind of an upside down division bracket type thing, or a sideways L, something like that. And that's just going to act as kind of an operator there, dividing our answer from what our work. Okay. Last step before we can start actually doing the synthetic division is I want to look at this bottom term here. And so to use synthetic division, it has to be something of the form x plus or minus something. So x can't have a coefficient out front. It just has to be x to the first with nothing out front, and then plus or minus some value here. And if that's the case, then we're allowed to use synthetic division. If it was x squared or 2x squared, then we wouldn't be able to use synthetic division, and we'd have to use polynomial long division. For now, I'm going to be giving you guys stuff that you can only use synthetic division on, so don't worry about that too much. I want to now look at the number that's either being added or subtracted to x. So in this case, we have x minus 1, and I want to flip the sign on that. So it's a minus 1. I want to flip that to a plus 1, and it comes over here to the outside. So it changed sign. So if it was positive, it would become negative. Negative, in this case, becomes a positive. All right, now I'm ready to go. So step 1, I bring down this first value. So I just bring down the 8. Now I take the 1 times the 8. So the 8 that I brought down, 1 times 8 is 8, and that goes up there. And then I add down. So negative 8 plus 8 is 0. Now once again, 0 times 1, well, is 0. So I put that up there. Negative, now I'm adding down. Negative 2 plus 0 is negative 2. I multiply. Negative 2 times 1 is negative 2. Put that up there. And 0 plus negative 2 is obviously negative 2. So first step, I bring down the first value. Then I multiply that by my number that's outside. So in this case, that was 1. I put it in the next column over, and then I add that column down. Right, so negative 8 plus 8 is 0. Negative 2 plus 0 is negative 2, and 0 plus negative 2, once again, negative 2. Right? So now I've got another list of numbers that still doesn't mean a whole lot to me. Now we've got to add back in the x's and give this some value. So I want to first separate off that last term. So you see that negative 2 there. I want to separate that off, and then I can start counting backwards. So this will be my x to the 0th term. This will be my x to the first term, and my x to the second. The issue with going the other way is you might start at x to the third, and you would forget about having the remainder, right? So first that negative 2 is sectioned off as the remainder, and then I work backwards. I have negative 2x to the 0ths. I have 0x to the firsts, and I have 8x squared. So let's rewrite that out. 8x squared plus 0x minus 2x to the 0th plus, and when we write our remainder, we want to do negative 2 over what we were dividing by. So we were dividing by x minus 1, so negative 2 over x minus 1. And we could simplify this a little bit more. We could get rid of this term, and we could get rid of the x to the 0. And so our final answer would look something like 8x squared minus 2 plus negative 2 over x minus 1. And that would be our original polynomial divided by x minus 1. Okay? So step 1, we are checking that it's in standard form and that we have taken care of any missing terms. Step 2, we pull off all of those coefficients and add the operator there, and then we take what we're dividing by, we take that number, change the sign, and put it on the outside. We perform our operations, and then we add back in those x's. So if we're dividing a polynomial, we should expect to be getting out a polynomial unless we've divided everything out, which is a very unlikely scenario, and I wouldn't anticipate that happening. Right? So that will be that for our synthetic division video. You will have some problems on your homework, so that's week 2, lesson 3, that talk about checking if something is a factor. The short story is, if you do synthetic division and there is no remainder, then what you were dividing by is a factor. I will cover that in a little bit more detail in another video, so keep your eyes out for that one. There should be a couple more coming out within the next few days. A review of graphing, review of what else? Factors and zeros, that sort of thing. So wishing you guys a good weekend. Feel free to reach out with any questions that you do have.